Change of scenery. All right, so now let's go ahead and get on to the next problem. So what are we going to do for this next problem? This next problem, I want you to take alone by yourself to work on. So the problem is, given an array of doubles, I want you to find the largest double and return it. So go ahead and, pause the video here and work on it. And what I want you to do is basically search an array, whatever is passed in. I want you to figure out how am I going to return the biggest double in an array of doubles. So say I get passed in a 1.0, 5.0, 23.0, 12.0, and 6.0. Okay, say you get passed in all these values, right? I want you to, if I get this if I pass in this array, I want you to return 23. Okay, don't want you to return 2. I want you to return the biggest value you find in there. All right, so you go ahead and pause the video here, come back a second, and let me know and figure it and resume when you're done. I mean, you really should go and try it. I mean, I know you're waiting for the answer, but go ahead and try it yourself. It's valuable. Come on. I'm sure you can do it. It's not as hard as the other one. You try it yourself. You're still there? Go and do it. All right. So let's go ahead and show you how to find the biggest number in an array. So you'll probably have something like this. So double biggest, which is the biggest value I've found so far. Now, some of you may have started out with 0, and that's fine. But at the end of the day, what you have is that basically I'm going to go ahead, I'm going to create a variable for the biggest. I'm going to search through everything in the array. And if it's bigger than the biggest number, that becomes the new biggest number. And I'll return the biggest at the end, after I've searched through everything and proven that that's the biggest. Okay, and that's perfectly fine, especially with my example where I gave you only positive numbers. However, of course, what if these were all negative numbers, right? This would have returned 0, but we'll get to fixing that problem later. That's kind of our edge cases here. Work on the generalized thing and then think about your edge cases. So, all right, so notice that we had different options under here. We had for each, for I. So I'm just going to go ahead and generate that automatically. So for int I is equal to 0, I is less than array dot length I plus plus, right? Not nums because I called it array here, but if you use nums here, so long as you used nums up there, that's fine. So the way I would code this up is basically if the ith value in the array is bigger than the biggest number, that biggest number becomes that ith value becomes the biggest number. Now, that's pretty much all it takes to solve this problem. Now, it's perfectly fine to break this up into one value if you're not comfortable just using array values directly like this yet. And I expect, unless you've actually been doing some Java before this, you might not be comfortable with that. So you might say something, you might like to store stuff temporarily. So double current val is equal to array I, right? So the ith value, or maybe we'll just call it the ith value. If the ith val is greater than the biggest, and that just makes it one line longer, but it makes it a bit easier it might make it easier for you to read or something like that. And that's perfectly fine. But now let's think about our edge cases. What if the biggest number in an array is a negative number? In this case, -1, right? And remember, biggest here, I'm using a shorthand for, longhand for maximum, or the max in the array. So So we're not looking for the absolute value. We're looking for the thing that has the most positive value to it. So in this case, it would be -1, but -1 is not bigger than our initial value of 0. So there's a couple of things we can do here. The first thing here is that we can basically do what I sometimes do, which is I say double. The biggest number is double dot min value. Sorry, not max value. Min value. So this is the smallest possible value, and it's highlighted right now on the screen, 0 times 0.0001 to the negative that times, I think that's, I'm not sure if that's in binary or not, but that's a very small exponent, as you can see. Doesn't matter if that's what base they're using for that exponent. That's a very tiny number. So what's in the array is probably bigger than that, right? And if the smallest value is, and if that value is in there, well, then you've already found, sorry, if they're all that value, then congratulations, you found it. So that's one strategy, because whatever you check is guaranteed to be bigger than this value. That's one strategy. Another strategy is that basically we use the very first value in the array and assume that's the smallest number until, or the largest number until proven otherwise, right? And as soon as we assign something bigger, we'll switch it. So in this case, let's go back to our non-edge case. Biggest starts at 1. Sorry, biggest starts at 1.0. We check 1.0 against 1.0. It doesn't change. 5.0 against 5.0. So our biggest is 5.0. Then it becomes 23. Then it becomes 12. Then it becomes 6. So that's fine. And you might notice that we're checking the first value twice. So in this for loop, we'll just start I at 1. But if you started at 0, that's perfectly fine too. So that's a good problem to try. All right. So let's go ahead and work on one more problem, a common problem I really like, and that's because it involves us having to do something we haven't done before. But before I do that, right, I had a for each option over here. So let's go ahead and just erase this for a second. Right, there was another option. So I selected the for I option over here, which created the iteration loop. What the heck is a for each? Well, I know what it is. That looks weird. So so there's a second type of for loop called the for each loop. And we can use this on arrays. You can also use it on other things, but the only thing you currently know how to use it on is arrays. But we can use this to create a much more concise loop when we don't care about the indices, right? Here, finding the biggest value, we didn't care about what indice it was stored at. We just cared about what the indice was, okay? So we could go, so for each double x, and then we read this as for each double x in the array. So for each of the doubles, for each double x in the array of doubles called R, if x is greater than biggest is equal to x. So this is a for each loop. It is a lot like the loop in Python, where basically where in Python you might go something along the lines of for x in R, right? So if you've taken Python, that's what this loop is. Only it just, the difference is what are we doing? We've replaced the colon, the in with a colon, because why not? And then we put parentheses around it. And then because we're in a strongly typed language, we put the type of each x in the array there. So this is the loop type that's native to Python, which is pretty cool, which is pretty nice to have. So just keep that in mind as an option. You will never need this loop for this class, but it's useful to know, and it's, you know, we definitely do not want you to get to the next class without knowing that it exists. It's much more useful when we deal with stuff that doesn't have indices. This is sometimes the only way to deal with that. But for right now, knowing that this exists is perfectly fine. Try it out yourself. Now, the important thing again is that you can only really use this when you don't care about the index. If you cared about what the index is, then you need to iterate through it using the indices because there's, as you can see, there's no index in here. Okay, doesn't even necessarily guarantee that's going to go in the order that everything appears in the array. Okay, but this is another valid way to do it. So, next. So this should return 2.0. 2.0. And now, at about, let's see, 1.9, 12, 3. Okay. And that's it. That 12.0 was the biggest one. All right. So, but this just works for, that works for my contrived example, which is perfectly fine for right now. All right. So now I'll go over, I think, one more problem with these, which I think is a tricky thing that you can try for yourself if you want a bit of a challenge. I think I might actually leave it as an exercise to the reader, so to speak. And this should be something that you might be able to do if you've tried the extra credit problem. It's not as hard as the extra credit problem. So, public static car most common. Oh, let's not give it a character. Let's go ahead and do string. All right. So let's go ahead and go over this problem. What is this problem that I just wrote out? Given a string that represents some text, so not necessarily just a word, could be a word, but could be something, like the entire works of Shakespeare that I just threw at you. Remember that big giant file of Shakespeare. There's no reason why we can't store that in a string, all 50 megabytes of it, except for, be slightly obnoxious, but we can do that. So given a string of text, I'd like you to return the most common character. So, and that sounds, and this gets into the reason, and this is a great problem for arrays because this gets into the, the reason we have arrays, right? Because you can imagine doing this possibly without an array. You can do something like int, okay, so int num a, so num a's is equal to 0, so the number of a's we've seen so far is 0. And let's ignore case sensitivity, but with characters you don't want to. Here's a variable for num b's. Here's a variable for the number of c's I've seen. And all the way, right, and you do a bunch of those. Int num y is equal to 0. Int num z is equal to 0, right? But instead, you could create an array to hold all these things, okay? There's actually a clever way you can use arrays if you remember that characters, right, correspond to strings. So I like this problem. It's a very, this is a very nice problem. I'm gonna leave this as an exercise for you to solve, but this is like something that is definitely a bit maybe too difficult to just throw at the exam for you right now, but it's a good problem. I like it. So go ahead and try working on it on your own. And if you want hints on it, you can come and email me for hints or come to my office hours. But this will return the most common, the most common string. You'll want to use an array of integers, I believe, to keep count of how many you find. So if you get HELLO, the answer would be lowercase l. So I'll just return. If I could spell return, I'll return space. that's generally a good move. Okay, so now I'll move on to the next video.